Good afternoon, everyone. Welcome to this course called as a short course on superconductivity. The course is fascinating for the following reasons. This suspension of objects with no visible means of support had been a very exciting and intriguing topic, which had even in this modern era, which is impregnated with technologies, it has been a surprising phenomena, and it has all been possible because of the discovery of superconductors and the phenomenon of superconductivity. So, we shall begin with the discovery of superconductivity that happened in 1908 in Leyden, which followed shortly after the liquefaction of helium, which was very much needed for seeing or achieving temperatures which are for this superconducting transition. And then we will take a look at the periodic table, and this will give us an idea that which of the elements can become superconducting and which of them cannot, and understand that why some of these materials become superconducting. We will take a note on what are called as type 1 and type 2 superconductors, take a look on Meissner effect, a very important phenomena that happens along with a superconducting transition, the flux quantization, which gives an elemental flux phi 0, and then we will take a look at or rather derive the BCS theory, the essence of the BCS theory, and look at the electron-electron pairing mediated by phonons and how that gives rise to an attractive electron-electron interactions. We will talk about the Bogoliubov of quasiparticles and how a specific heat discontinuity actually is a signature of a second order phase transition, which happens in the case of a normal to superconducting transition. We will also take a brief look at the Ginzburg-Landau theory, which is the only phenomenological theory which had happened before this microscopic theory came up, which is by BCS called as a Burdeen, Cooper and Schrieffer. We will look at the experimental techniques that determine the superconducting gap, which happens because there is the electrons form pairs and there is a certain amount of energy that is required to form the pairs. Look at experiments such as electromagnetic absorption, ultrasound attenuation and various tunneling experiments. And finally, we will take a look at the unconventional superconductivity and particularly D wave pairing and other exotic pairings, and high TC superconductors and iron based superconductors. I hope that you will enjoy the course and learn a lot of things about superconductivity, which are there is lots of research that is going on, and there will be the whole domain of the superconducting research will take a new turn as more and more materials are being discovered.